we're going to work through making a prediction on a multi-layer perceptron, or a standard neural network. In this problem, we're given a particular neural network, which we can view on this image, that has these particular weights, and given an input of dimensionality 3, so 3 different inputs to the neural network, we got to make a prediction, a binary prediction. That's why we have sigmoid activation at the end. So in this particular problem, we're given this exact neural network and given a vector of size 3 with 3 different weights, we got to make a prediction. So again, the neural network is already trained. So to code this, let's first remember that to make a prediction in a neural network, we can think of all of these edges as like the m's in the mx plus b of a linear equation, and we sum up all of the incoming arrows. So for example, for this hidden node here, it's going to be -3, that's the m, times whatever this input x is, plus 2, the weight of this arrow, times whatever the weight this x input is, plus -1 times whatever this input is. We sum those together, and that's the value of this node. However, to add non-linearities to the network, we need to add ReLU activation. So whatever the output of that summation of weights times input is, we take the max of 0 and x. We do the same thing for this node, and then using these two values, we do the same thing for this node. So let's code that up. And this is just good practice for how a neural network makes predictions. So I'm going to click on the solution on MLPro just to get these helper functions for sigmoid and ReLU, just to go a little faster. So the solution is a premium feature on MLPro.io. So if you ever want to see solutions to our problems, you could just hit the solution tab. So I'm not doing the entire solution, just these helper functions. So we have a ReLU function and a sigmoid function to help us out. Okay, so looking at the network, for this first node, we have an edge weight -3, 2, and -1, respectively. So we could maybe say that the hidden node 1 is going to be equal to -3 times the first input, x of 0, plus, what's the next weight? 2 and -1. So plus 2 times x of 1 plus -1 times x of 2. That's the value of hidden node 1, except we want to take the ReLU of all of that. Hidden node 2 is going to be ReLU of, let's just copy this whole thing and change the weights. So the weights for the second hidden node are it's 1, 3, and 7. Okay, so 1, 3, and 7. Great. And then finally, to get our output node, it's going to be the sigmoid activation, so apply the sigmoid function to whatever this weight, so this weight's 4, so 4 times hidden node 1 plus, and then we have a 2 here, so 2 times hidden node 2, and that should be our output. Let's see if it works. Moment of truth. And yep, that's the solution. So working through this is pretty simple, but it's just good practice for how a neural network makes predictions. Thanks for watching.